Alright, welcome back everyone to My Teacher. So today we are going to talk about permutations and combinations. I've prepared 5 questions for you. It will take probably around 40 to 45 minutes for you to complete. Now before we move on, please, if you like my content, do subscribe and like the video. Okay, let's get straight into it. Question number 1. So permutations and combinations. So the first thing that you need to do is knowing how to differentiate what is permutation and what is differentiation. So in usual cases, permutation. Oops, something wrong. Okay. So permutation will require some sort of arrangement. All right. So arrangements, order. So orders and arrangement matters in permutation. For combination, what actually matters is selection. So it doesn't really matter what order they are, as long as you're able to select a certain group of people, for example. Okay, so permutation is for arrangement and order, whereas combination is for selection. All right, so you will look into some of the keywords in the following questions as well. Okay. First question asks you to do arrangements containing 5 different letters from the word amplitude are to be made. Okay, so when there are no restrictions, how would we arrange 5 letters, okay, out of the word amplitude? Right, so what do we actually do? So we first take out 5 of these letters, spaces, okay, 5, all right, so I'm basically trying to fill up the number of different ways I can actually do the arrangement. So you don't necessarily need to do this. It's just to showcase for the first time. So you just take out of the 9, you take permutation of 5. So 9 pick 5. So you will end up getting quite a large number, 15,120. So it's quite straightforward. That's why the mark is given as 1. Okay, but it can get complicated, which I'll show later. Okay, what about a situation like this? The number of 5 letter arrangement which starts with A and ends with E. So this is where this type of model actually will be useful. Here I'm just writing it for fun. Okay, so now you will fill up the 5 letters with the A first and ends with E. So which means that out of the 9 given letters, because this is 9 letters here, right? So out of the 9, we have already chosen 2 of the letters. So we are left with 7 letters. Out of these 7 letters, I just need to pick and arrange 3 of it. Therefore, this entire thing would be 7 pick or permutation of 3. And 7 permutation 3 will actually give me 210. Alright, so that's it. Let's move on. Tickets for a concert are given out randomly to a class containing 20 students. No student is given more than 1 ticket. There are 15 tickets available. So find the number of ways in which this can be done. Now, put yourself in this situation. If you want to give out tickets, do you need to take into consideration of order and arrangement on how are you going to give the ticket? Nope, not necessary. As long as the 15 tickets are given out, that's it. So that's my goal. Therefore, this is not permutation. This is combination. So we have 20 students in the group, but I have only 15 tickets. So I can only choose 15 students. Therefore, this should give me 15,504. So combination and permutation, you can actually use the calculator. So you will have to use the calculator anyway. Right, let's go on. So the questions are fairly simple still. So let's say there are 12 boys and 8 girls in the class. Find the number of ways in which 10 boys and 5 girls get tickets. Now we still need to think about the previous situation. So because this is part of the same question, right? So how many tickets we are given? We are given 15 tickets. Keep that in mind, because our goal must always to give out all the 15 tickets. Just that now we have some sort of restriction. I want to make sure that 10 boys gets the ticket and another 5 girls will actually get the ticket. So how will we do this? We have 12 boys, but I'm going to only choose 10 of them. Okay, and out of the 8 girls, I only choose 5 of them. All right. So you might be wondering, why are we putting a multiplication here? Why is it not a plus? All right. So the reason is because whenever you see the word and, it's highly likely that we go with multiplication. Okay. If you see the word or, it's highly likely that we go with the plus or addition. Okay. Now the reason is because and means the what do you call that? The event is occurring at the same time. Okay. But or means I can have this event or another different event. Okay. So 2 different ways of doing it. Okay. So that's the main difference. Later I'll show you some examples of where or and addition will come into play. Alright, so you put this into the calculator, you should be able to get the value of 56. Oh, sorry, it wasn't 56. It should be 12C10 times 8C5. Let me just quickly put in my calculator. It's 3696. Okay. Alright, so next one. Okay, still similar part of the question. All the boys must get the ticket. Okay, so we have 12 boys here. So if everyone must get a ticket, it should be 12, choose 12. How many tickets are left? We are left with 3 tickets, and we only have girls left. So out of the 8 girls, we need to give away another 3 tickets. All right. So this will give me 56. Okay, I hope that you understand what's actually going on. If you find it difficult, just slow down the video again, repeat it, and then try to get it. All right, question number 2. So a team of 7 people is to be chosen from 5 women and 7 men. Calculate the number of different ways that this can actually be done. So when there are no restrictions. So when there are no restrictions, we want to choose 5 and 7, right? So total of 12 people that we want to choose. So if there are no restrictions, it's quite straightforward. Okay. Oh, sorry. I made a very, very careless error. It's not that I'm going to choose 12 people. There are 12 people available. Okay. And I need to choose 7 people. All right. So that means out of the 12, I will choose 7. Okay. And you get 792. Yeah, I think I need some sleep. All right. So the team is to contain more women than men. What about this type of situation? So in this case, you have to list down all the different possibilities where there are more women than men. Okay, so how can we choose? So we have 7 that we need, right? So I can try this. I can choose all the women. 5 women, all right, and the balance I would take at least 2 men. Right, so total makes up 7. So this is one possibility. Or, so I mentioned that I'm going to tell you that there is going to be an or. So this is the situation. So I can get 5 women and 2 men. Or I can have a situation with 4 women and 3 men. Okay, so up until here, my women are still more than men. If I were to reduce it further, okay, let's just try. If I were to reduce this further, I will end up with 4 men here. So then it doesn't make any more sense. So I would not take this. Okay, so we have an or situation, either this or this. So let's now do the calculation. If I were to get 5 women, okay, total 5 women, right? So I take 5, choose 5. What about men? I just need to take 2 of them. So there are a total of 7 of them. So I just take 2. Okay, so this should give me 21. What about this situation? So I just need 4 here. So out of the 5, I choose 4. And out of the 7 men, I choose 3. Kind of sounds like Pikachu, I choose you. Okay. Fans of Pokemon, rejoice. Right. This one, I'm going to end up getting 175. So, as I mentioned, when you have an OR situation like this, when 2 different possibilities, you end up adding them together. So when you add them together, you will get 196. All right, let's go on. So now it comes to a bit like 4-digit numbers. So if you're wondering what are the applications of permutation, this is one of the common applications. It's used to like calculate, especially in computer science, programming and coding. They use it to do calculations of number of probabilities of numbers and passwords and so on, combinations of passwords and so on, right? That's just one example. Okay, so how many different 4-digit numbers less than 5,000 can be formed using 4 of the 6 digits? You just need to take 4-digit numbers, right? So they said that the no digit can be used more than once. What they mean is that I cannot have 2, 2, 2, 2, for example. This cannot exist. Okay, that's not the situation that I actually want. So, all right, let's go back to here. We need 4 digits, and they must be less than 5,000. Okay, how do you make it less than 5,000? The first digit must be less than 5. So I can have a 4 in front, or I can have a 3 in front, or I can have a 2, or I can have a 1. So notice that there are 4 different situations here. So, but they are all the same, except the leading number is different. 5 and 6 are more, therefore you cannot use the values 5 and 6. So once you put a 5 here, the rest will become more than 5,000. Okay, so we have a total of 6 digits that are given. I've already chosen 1 digit, so I'm left with 5 numbers, okay, to choose from. I only need 1, 2, 3. Therefore, 5 P 3. Now, why do I use P? So this is arrangement. You're arranging numbers. Okay, arrangements in numbers matters. 4, 1, 3, 5. 4, 3, 5, 1. Arrangement matters. Both of them have completely different values. Okay, therefore you use permutation. So this will give you 60. And here is 5P3 as well. Here is 5P3, 5P3. So since there are 4, you just take 60, multiply by 4 times. So you get 240 different numbers. 4-digit numbers. You want to calculate your probability of getting a jackpot? Alright, you can actually do that as well. Okay, so you can actually use permutation and calculate the probability of getting a jackpot. It's crazy low. Okay, so how many of these 4-digit numbers are actually divisible by 5? Alright, so they are actually referring back to this question. Okay, so how many of these 4-digit numbers are divisible by 5? So you still have to make sure that they are less than 5,000. So let's try that out. Okay, so I'm going to write down all the different possibilities here. So in the first possibility earlier, I had 4, right? If I want to make it divisible by 5, my final number must always be 5, right? Or 0. But since I don't have a 0, I just have a 5. Okay. Now, the other situations are same. So I can have a 3 and a 5, 2 and 5, finally 1 and 5. So what matters here is that out of the 6 digits, 2 of them have been used up. So I'm left with 4 numbers. Okay, I just need 2 more. So out of the 4, I choose, not choose, my bad. Oops. Permutation 2. Okay, and because I need to arrange them. So it's the same here, 4p2 here, here, and here. Therefore, I take 4p2 multiplied by 4. 4 times 1, 2, 3, 4. So I'll end up getting 12 times 4, 48 different numbers or 4-digit numbers that are divisible by 5 and are less than 5,000. So that's basically how you do it. Okay, let's move on to the next one. All right, this one is quite an interesting question. Not extremely difficult, but quite interesting, especially part 2. Part 1 is quite easy. So an art gallery displays 10 paintings in a row. Okay, it's all in a row. Right, of these paintings, 5 are by Picasso, 4 by, damn, I have no idea how to pronounce this. Is it Monet? Okay, maybe. And 1 by Turner. Right, so find the number of different ways the paintings can be displayed if there are no restriction. This is quite easy. So 10 paintings, no restriction, you need to arrange them 10 factorial automatically. Okay, so factorial, we haven't been using factorial before, but yeah, when there are no restrictions and there's order involved, automatically you can just do 10 factorial, especially if you're using all of it. All right, so this should give me a huge number. I think it should be 3, 6, 2, 8, 800, if I'm not mistaken. Right, if I make any mistakes, please comment in the YouTube comment section. All right, let's go to the next one. This is where it gets a bit interesting. So they want to find the number of different ways the paintings can be displayed. In other words, they are saying how you can arrange them. Okay, if the paintings by each of these artists must be kept together. All right, so let's jog back our memory. So we had 10 paintings, 5 are by Picasso. So we had 5 Picasso. I think it was 4 Monet and 1 by Turner. All right, so it's a bit hard to imagine it in this way. Okay, so what I'm going to do is that I'm going to put them into blocks. You don't actually have to do it in real exams to show your working, but this is just for imaginative purposes. Okay, I mean illustration. Oh my god, I'm using the wrong words. 1, 2, 3, 4, 5. Okay, so this is by Picasso. Okay, I'm gonna then put another block. 1, 2, 3, 4. This is by Monet. And Turner is a bit lazy, so he just had 1. All right, so notice the different blocks. Okay, now imagine that in just this painting, I have to keep them together, right? But I can still arrange them in different ways. How many different ways can I arrange these 5 paintings that belongs to Picasso? Okay, 5 factorial ways. How many different ways I can arrange this? 4 factorial ways. How many different ways? Just 1 way. Doesn't really matter. Okay. Now, the problem lies when you stop here. Now, remember that these 3 blocks can also be swapped and arranged in different ways. So I can have this first, and then I can have this guy, and then I can have this guy, right? So notice that there are different arrangements. So you need to think how many different arrangements of these 3 blocks that I can have. The answer is 3 factorial. Okay, so I'm going to take 5 factorial multiply by 4 factorial times 3 factorial. So that's the final answer that you should be getting. So you will end up with 7,280 different methods, okay, or arrangement. Right, I hope that made sense to you. Okay, let's go on. Aha, so this is getting a lot more interesting. Okay, not this one. After this, I think it's going to become a bit difficult. Okay, let's see this. So I'm going to take my sweet time to explain number 2. So let's speed up a little bit. A committee of 4 seniors, all right, and 2 juniors are to be selected from a group of 6 seniors and 5 juniors. Calculate the number of different committees which can be selected. So what do we do? It's quite simple. Out of the 6 seniors, I just need to choose 4. Okay, this is combination, because we're just choosing. And out of the 5 juniors, how many are we getting? 2 of them. That's it. So you will end up with 150. 3 marks. Very fast. Just within 30 seconds you can finish it. Now comes the problem. Okay, so let's look at the problem here. One of the 6 senior students is a cousin of one of the 5 junior students. That means one guy here and another guy here, or a girl or anything, are cousins. Okay, so in total we have 2 cousins. One is a senior and one is a junior. All right. Calculate the number of different committees which can be selected if at most one of these cousins is included. At most. What does this actually mean? Okay, be very careful. At most means I can have a maximum of 1 cousin. Okay, so what are the different possibilities that we have? I can have no cousin at all. Okay, in the entire committee, none of the cousins are involved. All right, so it still falls within at most. Okay, so there is no minimum cousins here. If they say at least, then you at least have to have 1. The second situation is that we can have the senior cousin, right? And the third situation is that we can have the junior cousin only. Remember, it's at most. So I can either have this guy or this guy. All right, that's it. Then we need to do a calculation. But before I do the calculation, I just want to draw a very simple table so that you can kind of roughly visualize what's happening here. Okay, we have 6 senior students, right? 1, 2, 3, 4, 5, 6. Okay, imagine this is the cousin. Oops. Let me do something. Wait. Okay, I wanted to write senior cousin. Okay, so the rest of the seniors, this is the senior group. The rest of the seniors are just normal people. Okay, they are not cousins of anyone. Alright, I did tell you I'm going to take my sweet time explaining this. Okay, I wasn't lying. Okay, the second one, these are your juniors. They should have 5 people. 1, 2, 3, 4, 5. All of them are normal, except we have one junior cousin. Okay, so one is in the senior, one is in the junior. Now, let's then calculate the situation number 1. Okay, so situation number 1, there are no cousins involved. Right, so in this situation, I don't need any of this cousin. I don't care about them anymore. Right, so, but I still need to select the committee, right? So again, come back to how many committees that we need. A committee must be for 6 people. Okay, oops, not this. Yeah, you must have 4 seniors and 2 juniors at least in the committee. Right, so let me write that down somewhere here. You must have 4 seniors and 2 juniors in the committee. Okay, this is a must. Don't forget this. I almost forgot about this. Alright, so we have all the puzzle pieces. So let's do the calculation. So in order for us to have no cousins at all, from the senior group, okay, what can I choose? I have 1, 2, 3, 5 of them. So out of the 5, I choose 4 people. Alright, whereas out of the juniors, I have 4 of them left. I choose 2. Okay, I need 4 seniors and 2 juniors, right? So that's what I did. Okay, so here I'm going to get 30 of them. 30 different ways. Now in my second situation, I must have a senior cousin. Alright, so when I have a senior cousin, okay, I must include him. So let's assume that I've already chosen him because he must be included. Okay, so what happens? I have left how many people? 5 people. Okay, I have to choose how many now? Do I still need to choose 4? No, because I've already chosen the senior already. So I need to choose only 3 more. Okay, so I've already chosen the senior. Therefore, I only choose another 3. So total it makes 4. Okay, what about the juniors? It's still the same. I have to still choose. Out of the 4 left, I still need to choose 2. Why 4 and not 5? Because I cannot have another cousin. I already chose the senior cousin. Okay, and this should be 16. And the final situation. Okay, in the final case, I must have the junior cousin. Alright, in this junior cousin, what's going to happen to the seniors? Okay, this guy is going to go away. I don't need this guy, but I need this guy. Alright, so how many seniors do we have? 1, 2, 3, 4, 5. So from the 5, I still need to choose 4 of them. Now there will be some differences here. Out of the 4, I can only choose 1 because we have already chosen 1 junior cousin as a junior. Okay, so I don't need extra juniors. I just need 1 more. So in this one, I'm going to get 20. So what do? Final answer is add all this up. Okay, and it should give you 110. So that's basically how you do it. I mean, you can always find other methods to do it, but this is how you actually break it down into smaller pieces. Okay, so I'm just explaining in a very thorough manner so that everybody actually understands what actually going on. what's actually going on. My God, I think I really need some sleep. Okay, now let's go on. Okay, so this question is quite simple already. Sports team, 3 attackers, 2 centers, and 4 defenders, blah blah blah. So calculate the number of different ways it can be done. Alright, so they have so many people, but we just need to choose certain numbers. So for attackers, we have 5. We just need 3 of them. Okay. For center, we have 3, but we only need to choose 2. Right. Defenders, we have 6 of them. We only need 4. Alright. So when you put them all together in your calculator, it should give you 450 different ways. Quite fast and straightforward. Okay, let's go on. What about this? How many different 4-digit numbers greater than 3000 can be formed using 6 digits? Okay, so 4-digit numbers greater than 3000. So you just need to make sure that the numbers that you put here are more, you can put 3 in front, and anything that is more than 3. Okay, what else we have? Oh, we have 6. Okay, 4-digit, 1, 2, 3, total 4. So we have the balance. How do we get this? So out of the 6 digits, we have chosen 1. We are left with 5 digits. So we need to choose 3 more. Okay, and arrange them. So put permutation for arrangement. So one of it would give me, I think, 5p3. Okay, never mind. You can just take times 1 4 times. So 5p3 times by 4. You will end up getting 240. Yeah, this is 60. Okay. Let's move on. Permutation questions are almost always very, very similar. There are just some differences. What I try to do today is that I try to give you multiple different variations of the questions. Okay, but we have probably covered like 95% of it. Okay, so a committee of 6 members to be selected, blah blah blah. Find different committees that could be selected without restriction. So how many are we supposed to actually select? Okay, we are supposed to select, let me see. Okay, committee of 6 members, right? To be selected from 5 men and 9 women. So 9 plus 5, 14. Okay, choose 6 people. You end up with 3003. All right. What about the next one? When we actually need 3 men, okay, 3 men and 3 women specifically. So then you have to do something slightly different. Okay, so out of the total, we have how many men? How many men? We have 5. So what we're gonna do is that we're gonna take the 5, choose 3 of them. Okay, we have 9 women. We're gonna take the 3 out of the 9, and that's it. Okay, gonna get 840. Notice that once you know what to do, it becomes very simple. Okay, you can do it like really quickly. All right, last one. Then I'm gonna go and head to my dreamland. Okay, I still need to process the video, by the way. But anyway, all right. There is at least 1 man on the committee. Okay, there are 2 ways of going about this. So I'll show you the simplest way. Okay, at least 1 man. So at least 1 man means the opposite of at least 1 man is no man, or all women. Okay, so what we can actually do is that we can calculate the different ways of all women, okay, and then we minus by the total, because everything else will have a man except for a situation where everyone is a woman. So we can do that. So for that to be true, we take 9, because we had 9 women, we choose 6. So all of them are women. So this will give me 84 different ways. So I can take the total probability, okay, I mean total different ways, minus by all women. So that is total what? Total was already given here. 3003 minus all women. So we will end up getting 2919. Okay, this is the fastest way. There is, of course, the long way to calculate all the possibilities where a man is involved, or at least one man is involved. So what can we do? If you really cannot think in this way, we can always try and list down everything. So probabilities are 1 man, 5 women, 2 men, 4 women, 3 men, 3 women, 4 men, and 2 women. Okay, so then yeah, list out everything that you can. So that's basically how we can do it, and then you calculate everything, you will also get 2919. All right, so I think we're done. Yep, we don't have any more questions, so I'm going to leave it there. Did I miss anything? Let me see, double check. Okay, yep, so yeah, list down everything, so there might be more. Okay, so that's basically it. So if you enjoyed the content, please share the content with your friends, peers who are also taking up the exams, so that it can be helpful for them. And yep, so subscribe and like the channel. Thank you very much. I mean, like the video. Thank you very much. See you all in the next video. Bye bye.